OK, so now we're going to get into the meat of today. This is the fun part. So now we're going to actually see what x86 does when it calls a function. So I hope you're excited. This is the fun part. So let's say I have some code that's like main, and it calls a function called foo. So when I call foo, what do I have to do? I need to go to foo. I need to run whatever foo says to do. So foo has some code. I have to run that code. And at the very end of the function, it says return, which means I have to go back to main and finish up whatever main is doing. So the rest of today is dedicated to answering this question. If I am in main and I call foo, how does this function call execute in x86? How do I go to foo, execute all these instructions, and go back to main when I'm done? This is what all of today is going to be about. So sometimes people call this calling convention. I'm not going to read all this stuff out because we're going to see it in a demo. But the important thing is we need to design this in a way that everyone knows about. So everyone's going to use the same rules to call functions. And by doing so, we're going to make sure that we never lose data, that we never overwrite data that other functions are depending on. So we're going to design this in a way such that if everyone follows the rules, we're not going to lose data. When we call a function and the function returns, everything's going to be left back where it's supposed to be. So it's kind of like, if, I don't know, if your parents go out and you want to steal something from the cookie jar, you can do that. You just have to put everything back where it used to be so that when your parents come home, they don't notice that anything is wrong. That's kind of the analogy. OK, so this is kind of what it looks like. So before the function calls happens, you're going to be in main. So here you are, you're running main. Everything is good. You have the EBP pointing at the top of the main frame. You have ESP pointing at the bottom of the main frame. And your EIP, that's the instruction pointer, that's pointing at the code of the caller function, which is main. So remember, the EIP tells you which instruction is currently executing. It holds an address. If you go to that address, you'll find an add instruction or a multiply instruction that's currently executing. And right now, it's pointing at the instructions of main. But now you want to call foo. So what are you going to do? When you call foo, a bunch of things have to happen. One thing that has to happen is you have to make a new stack frame. This is the space that foo is able to use to store local variables, do computations. Whatever foo wants to do, it has to do down here. And when I make a new stack frame, EBP now has to point at the top of the new stack frame, ESP at the bottom of the new stack frame. This is a new space for foo to use. And also, the EIP, the instruction pointer, used to be pointing at instructions in the caller. That was main. Now we have to switch it so that it now points at the instructions in foo, because I'm now executing instructions in foo. So when we call a function, these two pointers have to drop down to make a new stack frame, and EIP has to move to call or to point at the functions in the instructions in foo. EIP points at the instructions in foo. That's what I said. OK. And finally, when foo returns, we need to put everything back where it used to be. We can't leave a gigantic mess for main to clean up. Foo is going to be responsible and clean everything up so that when we go back to main, everything is as we left it. So when we are done, when foo returns, we should put EBP back where it used to be. ESP goes back where it used to be. EIP points back at the code in main. So everything is back where it used to be. And main can continue like nothing happened. So when foo is done, we need to restore the stack so that everyone goes back to their old positions and main is able to continue running. So that's our goal. We're going to call a function, shift all these registers, and then when we're done, we're going to put the original values back in the registers.